So I'm doing recap chapter 3, and kita dah belajar that we have two conditions, which is system in equilibrium, which means that acceleration needs to be equal to 0. This is the condition, A equals to 0 or net F net is equal to 0, or you can write it as F like that. Now, when you have F net equals to 0, it means that both the Fx and the Fy, the net in the Fx and net in the Fy is also equal to 0. Okay, so that is our condition. Why is this arrow so ugly? Kejap. Okay, tak rupa arrow dah. So net in the Fx and net in the Fy is equal to 0. So this is when your system is in equilibrium. How do you know if it's in equilibrium? It's not moving, or it has a constant velocity. Macam mana kita tahu ini condition untuk sistem in equilibrium? Because not moving and constant velocity equals to A equals to 0. Dia berkait dengan A equals to 0. Constant velocity. So from here, you have two conditions that you need to use with your free body diagram. And then whatever is in your free body diagram, you resolve all your forces into your chosen axis. For example, kita ada incline. So we know that motion, it can be here or it can be upwards if there's someone pushing it. So we know that motion is along this incline. So therefore, you choose your axis along the motion. So this becomes your x-axis and this becomes your y-axis. So in normal cases where the box is on the ground, or we're talking about yourself, or we're talking about an object on the ground, then you know that the motion can either go left or right. Therefore, your axis that you choose should be parallel to the motion. This will be your x and this will be your y. And then remember, if you have mg, something that I need to remind you guys again and again, if we have mg, this is on an incline. Mg macam ni. Mg bukan macam ni That is wrong. But this is going to be the component of mg. So this is mg cosine theta, and this will be mg sine theta. And friction will always be opposing motion. And then we have normal force if we are on a surface. What else? If we have a string, we will have tension. So these are the things that you need to remember. Okay, so that is for equilibrium system. What about linear motion? Linear motion, let me make this bigger. Why is it so small? Okay, so system in equilibrium was the first case, and then system in linear motion. Specifically, when A is not equal to 0. Sometimes we have constant velocity, we can also call this as linear motion, but the system in linear motion in this case is specifically when we have acceleration, or acceleration is not equal to 0. So we are moving. We can move either up or down, or right and left, or on an incline, tak kisah. So if it's going up and down, therefore we know that your F net in the Y will be equal to MA. And if you are not moving left and right, this guy becomes net in the Fx equals to 0. Ni kalau kita terbang. Korang lah terbang, saya tak terbang. So you guys are like flying upwards. You have acceleration going upwards, but you're not moving to the left or right, tak ada So we just have net in the Fy equals to MA. Apakah M? M is your mass. M is your mass and A is your acceleration. Okay, going up motion. What if we have a car? Why? I don't know how to draw a car now. Okay, so your car is moving to the right. It has some acceleration. Okay, it has some acceleration. It's not flying. Therefore, your condition for this car is going to be net in the Fy equals to 0 and net in the Fx equals to MA. What m is this? It's the mass of the car, acceleration of the car. And then you need to know how to draw your free body diagram because you need your equation, you need to write your equation based on your free body diagram. So that is our recap. Any questions about our recap before we continue with examples? This saya nak suruh korang try pula. So everyone's okay? Understand what we're talking about? Okay.
Okay.
All right, that's good. So let's talk about this example again. We already talked about it, but let's just do a recap balik. So a 45 kilogram box is kept from sliding on an inclined plane. So kept from sliding, kita halang dia daripada bergerak. So we know that A is equal to 0. So this is a system in equilibrium. An inclined plane by a string parallel to the plane. So string, immediately I know that I should be having tension. If the coefficient of friction, terconfuse saya, fraction pula. Friction is 0.2 and the plane is 50 degrees to the horizontal. What is the tension of the string? So kita dah lukis free body diagram kita ada mg, kita ada mg sin 50, kita ada mg cosine 50. This is our angle over here. And then we have normal force ataupun reaction force. And then we are assuming that our box is moving has the tendency of motion to the right. Therefore, we will have a friction opposing that motion. And then we also have a string opposing that motion. So sekarang ni kita ada friction and also tension to prevent this box from sliding down. Kita ada dua lah. Satu friction, permukaan tu bagi dia tak menggelongso. Satu lagi ada tali yang tahan dia daripada menggelongso. So now that we have completed our free body diagram, we write our condition. And then using this condition, we write our equation. So net in the Fy is also equal to R minus mg cosine. So R is going to be positive and mg cosine theta is going to be negative. And then this is going to be equal to 0 based on the condition over here. Nanti bolehlah solve R jadi apa semua kan. And then net in the Fx equals to 0. We already know that. So what is in our x-axis ataupun our parallel axis? We have mg sin 50. This is also 50. We have positive mg sin 50. We have minus t and then minus f. This will be equal to 0. And then we will, eraser. And then we need to solve for friction. Friction is mu r. First, I need to know what is R. R is mg cosine 50. Then mu is 0.2. Sebab laju-laju sebab ni kita dah tahu. So mg cosine 50. Okay, so that will become 45 times 9.81. Kat sini tak ada negatif G dia. Only in linear kinematics that you need to include the negative sign. So 45 times 9.81 times cosine 50 times 0.2. So 0.2 times 45 times 9.81 times cosine 50. So this will become 88.93. Betul tak saya kira ni? And then mg sin 50. So this is 338.17 minus t minus 88.93, and this is going to be equal to 0. So you can solve for t. Okay, so it's easy. When it's in equilibrium, it's quite easy. So sekarang kita nak go for the harder ones. Okay, I'm going to show you guys how to do an example of a linear motion yang ada MA. And then for the next example, I'm going to expect you guys to help me ataupun to do it for me. Okay, so this one, a 15 kilogram box is released on a 32 degrees incline. So please pay attention how to do MA punya situation. 32 degrees. and then accelerates down the incline at 0.3 meter per second squared. So this is your A. I need more space to draw my free body diagram. Sekejap, saya buat besar sikit. So this is 32. This is my box. It's supposed to be touching, and then my motion is down here. A is equal to 0.3 meter per second squared. Okay, find the friction force impeding, it's asking for F, impeding its motion. What is the coefficient of kinetic friction? So it's asking, mula dia tanya friction force, lepas tu tanya mu. So of course we need to solve for friction first before we can know what is mu, right? So let's draw a free body diagram. Kita ada A kat sini. We have mg down here. Draw my axis. And then we are supposed to have friction opposing the motion. That is your friction. You have your reaction force. Okay, apa lagi? Saya kena resolve my mg. So this will become mg cosine theta. And this will become mg sine theta. Okay, what else? Do we have tension in our free body diagram? Do we have tension?
No.
No, Okay, so what else? Are we missing anything here? Cuba fikir, ada tak kita miss anything? Or is this complete? What do I do with my acceleration? Should I put it into my free body diagram? Anyone wants to try? Yes, no? So tak tahu, tak ingat dah. Okay, so your acceleration is not a force. Kita letak force sahaja, betul? So Daniel jawab, kita letak force sahaja. So acceleration is not a force yet. So I mean, we know that it's accelerating, but kita tak tahu dia force apa. Macam mana cakap? It's not part of the free body diagram lah. It's just indicating the motion. So it's a condition. So kita punya free body diagram hanya letak force. Your acceleration, you don't have to include it in your free body diagram. Cukup sekadar letak arrow indicating the motion A equals to apa. Okay, so now we write our condition. What is the condition for my Fx? Is it 0?
No.
MA. Okay. So it is MA. What is the condition for my Fy?
0.
Of course, it's not flying. Okay, great. So everyone on the same page now. So MA, what is in my x-axis? I have positive mg sine theta and I have minus friction. So this is equal to MA. Okay, I use my condition over here. This is from my free body diagram. And for my F net in the Fy, I have R going upwards, so that's a positive, and then minus mg cosine theta, and this will be equal to 0. So I can solve for this. Mg cosine theta, m is 15, we are referring to the box. G is 9.81 cosine of 32, and this would give me 124.79 newtons of reaction force. So we solve for this guy. Now we want to solve for our MA equals to mg sine theta minus F. We don't know what our F is, but we know what is our R. So we need to solve for F first because we also don't know what is our coefficient. So M is 15, A is 0.3. I'm going to assume that it is a positive. Kenapa saya cakap dia kena positif? Sebab saya dah declare mg sin theta ni. Tadi saya declare mg sin theta ni as positive kan? Ini dah positif. Maksudnya ke kanan, semua yang ke kanan adalah menjadi positif. So, therefore my A should also be positive. Positive 0.3. And then this is 15, 9.81 sine of 32 minus F. So the only unknown here is going to be F. So we can solve for F, which is, I don't know. So F bawa ke sana, F bawa ke sana, this guy bawa ke sini. So 15 times 9.81 times sine 32 minus 15 times 0.3. That would give me friction as 73.48 Newton. Okay, so this is R. Okay, so now it's asking what is the coefficient of kinetic friction. So dah senang dah lah kat sini. Kita tahu equation untuk friction is mu R. Friction is 73.48. Mu is unknown. R is 124.79. Oops. 124.79. So that is going to become saya silap kira. 73.48 divided by 124.79. Mu is going to be 0.59. Okay. Saya ada chat kejap. Okay, sama. So Aida pun dapat jawapan yang sama. Thank you. 0.59 ataupun 0.589. Doctor, why is gravity positive in this chapter but negative in linear kinematics? Okay, sebab kita dah include the negative sign for gravity inside our free body diagram. If you look at this free body diagram, kita punya arrow going down, mg cosine theta. This is related to gravity, right? Sekejap saya tulis. Yang ni adalah gravity. So kita anggap dia negatif kan? So when I was writing my equation, I wrote R minus mg cosine theta. So minus untuk gravity tu dah ada dalam ni. So kita tak payah letak kat sini. So we only refer to the free body diagram. Okay? So kalau kita tak pakai approach free body diagram ni, let's say you know that there is a reaction force and there is some component of gravity going down. You said, okay, I want to add both of these forces together. Boleh. So plus mg cosine theta. And then you said, oh, gravity is going down. So this guy becomes minus g. Boleh juga, sama je. But kita dah ada cara yang senang, which is follow the free body diagram and then write the equation. So we choose this approach so that tak ada confusion. So again, linear kinematic kena letak negative g sebab kita tak ada free body diagram. Tapi bila kita ada free body diagram, we follow the arrow to write our positive and negative. The rest is only magnitude. Okay? Faham eh? Kalau kita ambil 0.6 accepted ke doktor? Saya nak 2 decimal places eh. Always try to give me 2 decimal places. Okay, next. Yang ni nak suruh korang buat. Yang ini dah ke... not this one. Sekejap, kita ambil yang lain. Ini dah buat. Okay, jawapan sama 0.59. Okay, this one. Kenapa tak boleh adjust? Okay. Aish, lama pula. Okay. Sekejap. Okay, so let's do this one. A crate on an inclined plane is connected by a string to a free suspended load. So saya akan lukis gambar, kasih hint kat korang, lepas ni korang solve kan. So small frictionless pulley, it is on a free suspended load. Sekejap. Kita cakap incline kan? Oh, it's an incline. And the angle of the inclined plane. Okay. So ada incline. So kita anggap dia macam ni. So this is 50 degrees. Your box is 1 over here. Okay, a crate on an inclined plane is connected by a string over a small frictionless pulley. So apakah yang kena ingat kalau frictionless ataupun smooth pulley? What do you need to remember? To a free suspended load. So the suspended load is here. So what does suspended load mean? It means the gantung. If the mass of the crate, this guy, M1, M1 is equal to 50 kilogram, and the mass of the load is 40, this is M2. M2 is 40 kilogram. The coefficient of friction is 0.2. Okay, and the angle of the inclined plane is 50 degrees to the horizontal. What is the acceleration of the system? Okay, so kita ada dua free body diagram. So banyak kerja. So saya akan agi-agikan macam biasa. So let's pick names. Boleh ke saya nak Aida untuk buat M1? Okay, Aida buat free body diagram of M1. And then I want Adli free body diagram of M2. Okay, and then saya nak condition. Condition saya nak Anik. Anik buat, ni huruf A pula. Condition net in the FX. And then arti FX untuk M1. Okay, banyak ni nak kena buat. So saya akan agihkan. So Daphne. Saya rasa saya selalu panggil Daphne. Sorry Daphne. So Daphne buat condition net in the FY for M2. M1. Okay. Banyak ni. Okay. Lepas tu Hazira. Hazira kita nak condition. Kita nak condition dengan equation ke tak Kita kasih orang lain lah buat equation Okay, Hazira condition net in the FX for M2. Ifa condition net in the FY M2. Okay, kita nak buat equation pula. So equation is Ikri. Ni equation. Ikri Ni Ikri tau. Tulisan saya buruk. Lepas tu this one. Equation is going to be Iqbal. Okay, untuk Hazira, untuk condition F net interface for F2, equation kita nak siapa buat? My and then equation Najla. Okay, so macam separuh kelas je? Okay, tak separuh kelas, 1/4 maybe. Okay, so let's take 7 minutes. The rest of you, please try it yourself. Soalan ni soalan yang boleh masuk exam. So this is like the common type of question. So 7 minutes, is it okay? Sebab kita dah bagi-bagi kan? Should be okay. So 7 minutes for our lucky volunteers. Walaupun saya yang pilih. 7 minutes, so we have 2:41. Kita akan discuss PM. Okay. Kalau soalan boleh tanya Condition tu bermaksud adakah dia punya net force equal to 0 ataupun net force equals to MA. And kalau MA, apakah direction dia? Okay. Okay, one more minute. Okay, dah habis masa So let's ask Aida. Aida dah siap ke free body diagram untuk mass number 1?
Ya, Doktor.
Okay, so how did you do it? Let's see.
First, we have the gravitational force to the downward,
Okay,
and then we have the normal force to the
okay.
upward.
Macam ni? Is it?
Lepas tu ada apa? mg cos theta.
Okay, where is that? Ke kanan ke?
No, ke bawah.
Okay. So we have this.
And then sudut tu dia 50 degree.
Okay.
And then we have mg sin theta ke kanan. Lepas tu ke kiri kita ada tension force dengan friction force.
Okay, so Aida cakap friction force dia ke arah sini. Okay. Kita kena tengok. Okay. Okay, jap What else? Itu saja ke? Okay. Thank you, Aida. Okay, so that is free body diagram number 1. Let's talk about it. Reaction force, because the crate is on the incline, so ada touching the surface, so ada reaction force. Mg is just the normal gravitational force. The resolve jadi mg cosine theta, and to the right mg sine theta. So Aida is assuming that motion kita ke kanan, kan? Betul kan Aida? That's why Aida letak friction together with tension. Am I right?
Yes.
Okay. Okay. Next, Adli, free body diagram number 2.
Okay, Doktor. Dia ada dua force.
Okay, which is?
Satu kat bawah mg.
Okay.
Atas tension.
Atas is tension. Okay.
Hmm.
Itu saja.
Itu saja.
Okay, Adli nak tanya lagi. So tension dekat awak punya mass ni adakah sama dengan tension untuk free body diagram AIDA? Berbeza ke sama?
Hmm. Sama kot.
Sebab?
Sebab dia tergantung.
Okay, dia tergantung. Okay, jawapannya sama tapi bukan sebab dia tergantung tapi sebab dia cakap dalam soalan is a frictionless pulley. Okay, kan saya bagi tahu kalau pulley korang smooth ataupun frictionless, tension yang bersambung dengan pulley ni akan sama. So kat sini dia smooth Okay, so take note semua orang and Adli. Kalau dia smooth,
Right.
tension akan sama. Okay. Next. Hazira, condition untuk net in the fx for, kita start dengan Anik dulu. Anik, what is the condition for net in the fx for mass 1?
F equal to MA.
F equals to MA. Okay, where is your axis for this net in the fx? Is it parallel to R or is it parallel to T ke apa?
Parallel to T.
Parallel to T. Okay, so this is your net in the fx. Okay. Okay. So MA awak ni, is it to the right or to the left? Is it the same as AIDA ataupun ke kiri?
Sama macam AIDA.
Okay, kita nak pilih sama macam AIDA. Okay, kita pilih sama dengan AIDA. So kita akan cakap yang ni positif ke negatif? Banyak pula soalan kan? Sorry. Kita nak cakap positif ke negatif? A kita ni.
Positif.
Positif So awak nak cakap A dia positif. Okay, kita go with that first. So this will be a positive. Kita jangan tengok betul ke salah And then Daphne. Daphne, condition for net in the FY untuk mass number 1. What is it?
Net in the Fy equals to 0
Why is it equal to 0?
because it's not flying.
Okay, because it's not flying. Okay, thank you, Daphne. And then Hazira, what is the condition for net in the FX for M2?
Fx equals to 0.
Fx equals to 0. So where is your axis untuk mass 2 Untuk X dia. X axis untuk mass 2 dekat mana?
Dekat center of the box.
Okay, kat center. Tapi dia ke atas ke kanan ke kiri ke?
Ke kanan.
Ke kanan. So macam ni. Macam tu. Tu axis awak. Okay. Equals to?
0.
0. Okay. Why is it equal to 0? Hazira kan? Hazira. Why is it equal to 0?
Not moving to the left or right.
Okay, because it's not
Going
moving.
upward.
Alright. Okay, betul. Thank you. So Hazira jawab dengan betul. So Ifah, what is the condition for net in the FY for mass number 2?
Condition for Fy is equal to MA.
MA. So is it going upwards or downwards?
Upwards.
Upwards. So kiranya nak ikut AIDA lah semua orang ni. Semua orang nak ikut AIDA. So kalau dia pergi upwards, A ke kanan lah kan? Okay, so kita panggil dia atas positif jugalah. Okay. Okay, now equation. Let's see. Let's use green color. Okay, so equation untuk mass 1 is Ikri. This one. What is the equation, Ikri?
mg sin 50
Sin 50. Betul? Lagi?
plus f
Is it plus or minus? Kau tengok gambar ni. Mg sebelah kanan.
plus
So friction.
kanan.
So your friction is to the
Friction
right.
ke kiri Okay, minus f.
So minus F. Tapi awak buat dalam free body diagram awak positif F
Yes.
Okay, boleh juga. Nanti kita tengok salah ke betul. Okay, sebab kita tak tahu kita punya box ni moving to the right or is it going to the left actually. So if you said it's positive, then it's okay. And then what else?
F equal, is it?
What is the equation for net in the fx? Mg sin 50 plus
Plus F.
lagi satu.
I don't know.
Okay, tengok kat sini free body diagram yang Aida dah lukis ni. Apa yang dalam axis
Tension.
dia? Tension. Okay, so tension adalah direction ni ke kanan ke kiri?
Ke kiri.
Ke kiri. So dia terbalik dengan mg sin theta. So dia punya direction sama ke tak? Tak sama kan? Okay, so dia jadi positif ke negatif?
Negatif.
Negatif. Okay. So kita akan follow Aida punya free body diagram dulu lah Ikri, walaupun awak cakap friction ni positif, kita ikut Aida punya example dulu, kita akan tengok betul ke salah So this will be negative. Okay, kita ikut free body diagram Aida dulu. Thank you. So faham ke macam mana nak tulis equation ni Ikri? Dah faham ke?
Faham Doktor.
Kena buat banyak example lagi Alright, so next one. Iqbal, net in the Fy equals to 0. What should be in the equation?
Normal force R.
Okay, is it positive or negative?
Positive.
Positive R.
Minus mg cos 50.
Okay, what else? Ada lagi tak?
Tak ada.
Tak ada dah. Okay, great. So thank you Iqbal. Next is Mai.
0 equal to mg.
0 equals to m. Awak buat fx kan? Mai. So dalam x awak ni ada mg ke?
Tak kot.
Tak ada kan? Jadi tak payah letak apa-apa kan patutnya.
Oh, okay.
Okay, so apa-apa yang dalam axis kita sahaja kita letak. So kalau tak ada, tak payah letak apa-apa. So just that lah, you don't have to solve for it lah. Okay Mai? So that was a trick question.
Okay.
So when you don't have any forces in your axis, do not write any equation lah. Sebab tadi equation kat situ. Okay, thank you Mai. Najla ke ni? Najla. Net in the Fy. Najla? Najla not there? Najla ada ke tak ni sebenarnya? Let's see, Najla ada. Hello. Okay, Najla is gone. Mai, can you help me? Mai boleh jawabkan tak? Untuk net in the Fy.
MA equal to T minus mg.
T minus mg. Kenapa T positif? Bukan
sebab
minus.
Dia ke atas.
Dia ke atas. Okay, so kalau saya pilih ke atas as positif, semua benda yang ke atas adalah positif. Kat sini saya cakap A positif kan? So apa-apa yang ke atas should be positive as well. Okay, thank you Mai. That was really helpful. Okay, kita dah buat equation kita. Saya tak tahu sebenarnya friction ni ke kanan atau ke kiri. Kita akan tengoklah dia jawapan dia betul ke tak. Selalunya kalau soalan macam ni dia akan cakap incline ni smooth. So that kita tak payah fikir pasal friction, tapi dalam soalan ni ada pula. So kalau friction dia smooth, maksud saya if the incline is smooth kan, permukaan kat sini smooth, soalan dia cakap the incline has a smooth surface. Sorry. Therefore, you don't have any friction. So tak ada friction dalam awak punya equation. So tak ada lah. Tapi in this case, dia cakap ada kan? Ada yang ni. So kita buat je lah. Okay. And then another thing that you need to remember is if your pulley is smooth, your tension is equal. Okay, so this is, you need to remember it yourself. Tak ada hint dalam exam nanti. Doktor, sorry saya lambat. Okay, it's okay Najla. Pergi toilet Tak apa. Okay, so now kita dah ada equation kita. So net in the fx tak payah solve sebab tak ada equation to solve. What else do we know? So we know what mass 2 is. Okay, and then we don't know what our MA is. Do we know our tension? Not yet. What else do we know here? So R, kita tahu mg. Yes?
Tak ada, sorry.
Oh, tak nak tolong saya ke? Okay. So kita tahu mg cosine 50. So R is equal to mg cosine 50. So we know what this is. This is mass 1 times gravity times cosine, right? So mass 1 is, saya tak nampak, 50, 9.81. And then this is cosine 50. You get your R. So this is equal to 50 times 9.81 times cosine 50. That is 315. Okay, so what else? What should I do next? I know my R, friction. Okay, thank you. So friction is equal to mu R. So we have our mu, so we can actually find our friction. So that is right. 0.2 times 315.29 will give our friction. So times that with 0.2, 63.06 Newton is our friction. Okay, so we have our friction. What else? What else can we do?
And the tension.
Find the tension. Okay, someone said find the tension. So kita solve this equation with respect to tension and solve this equation with respect to tension. Okay, let's do that. So T is our subject. So I'm bringing T to the other side. So I have mg sine 50 minus friction 63.06 minus, sorry, I'm bringing this guy over here minus MA. MA tak tahu lagi apa kan? And this is specifically for mass 1. So I need to label mass 1. Mass 1. Okay, next. I'm trying to solve this equation with respect to T. So I say T is equal to MA plus MG. In this case, this is specifically for mass number 2. So M2G, M2A. Okay, so now that I have T and T, what can I do with this?
Compare.
Equal. Replace.
Replace. Okay, I can equate them together. Okay lah tu jawapan lebih kurang lah kan. I can equate these two equations together because they are basically T. So I can say, oh, this guy, number 1, is equal to this guy, number 2, because T is equal to T. So I need more space. Kejap. Group. Datang dari sini kan. Okay. So this is from here and this is from here. Okay. So now I'm going to equate them together. Let's use a different color for that. Let's use pink. Okay. So T over here is equal to T over here because T has the same value. So saya boleh equate them together. So M1G sine 50 minus 63.06 minus M1A equals to, apa saya suka letak ujung-ujung, saya tak cukup tempat. Sekejap. Okay, saya buat kat sini . Okay, this is equal to this guy over here, M2A plus M2G. Okay, now I put in all the values that I know. So I know what is mass 1. Mass 1 is 50. So ini macam math je lah. Sin 50. Kita punya physics, kita dah buat kat free body diagram tadi. So minus 63.06 minus 50A. So this is what I have. This is equal to, the mass number 2 is 40 kilogram, 40A plus 40 9.81. Ingat dalam equation ni tak ada negatif G. Negatif semua kita dah settlekan dalam free body diagram. Okay, so now I try to kumpulkan my A's together because my A is my unknown. So I'm going to say that this is going to be equal to 90A. Saya kumpulkan 50 ni to the other side. This guy I bring to the other side. So I have 50 times 9.81 times sine 50. Okay, so I get 375.74 minus with 63.06 and then minus with 40 times 9.81. Oops. Hopefully it's right. So it's minus 79.72. Korang dapat jawapan sama ke tak? Sama Okay. So now I have this guy to a minus value and the other side is 90A. So if I want to solve for A from this equation, I can say that divide je lah kan. Minus 79.72 divided by 90. So the answer is minus 0.88. Sorry, 89 meter per second squared. So now my question is, kenapa dia negatif? Cuba teka kenapa dia negatif. What does it mean when it's negative? So we said that to the right is positive, but we get the answer as negative. What does that mean? Dun, dun, dun. So this is something that you need to know. This is a learning curve lah for you. So when our answer is negative, it means that our assumption in our free body diagram is terbalik. Okay, it means that. So if, I'm going to repeat myself, please focus. If I get my answer for my acceleration as a negative value, it means that my assumption in the free body diagram is incorrect. Incorrect in the sense that the motion is going in the opposite direction. So sebenarnya dia punya direction adalah terbalik motion dia. So this means that my friction is also terbalik. Itu maksud je dekat situ. So saya kena buat balik lah free body diagram ni sebab friction dia terbalik. Motion adalah ke kiri. So saya kena buat kat sini positif. Dan ada lagi-lagi benda yang saya kena adjust lah. Tapi pengajaran kat sini if your answer is negative for your acceleration, it doesn't necessarily mean that your answer is wrong. It just means that your direction of assumption is incorrect. Dia terbalik sahaja. So what if your answer is negative at the end? Will I accept this answer? Yes. Sebab it is based on your assumption and we don't know. Assumption ni benda yang kita tak tahu kan. So Aida assume the acceleration is to the right. Tapi sebenarnya acceleration is to the left. Tapi at the end Aida prove that the acceleration punya magnitude is negative. So kalau Aida tahu yang negative means that the direction is the opposite way, then your answer is still correct. But if Aida said, oh, dia walaupun negative acceleration tapi direction dia tetap ke sini, so tu salah lah. Okay, you have to know what it means when it's a negative. Okay, kalau dapat jawapan negatif maksudnya motion terbalik. Okay, okay ke? Okay ke? So semua orang macam, what is this? It's a new thing lah, okay? Kita akan buat lagi satu example. This time I'm going to ask you guys again. Hopefully tak ada friction sebab friction ni memang akan kacau kita punya jawapan. Sebab motion dependent on friction, right? So selalunya soalan macam ni dia akan kasih kita frictionless incline. So that jawapan kita tak ada masalah dengan friction. Okay? So selalunya macam tu. And kalau negatif pun jawapan dia tak betul. Okay, so kalau kat tengok kat sini, F dia, this is the answer. F dia adalah this way. F dia adalah this way. Sama direction dengan mg sin theta. Kalau tengok kat sini, F kita terbalik daripada mg sin theta. Tapi tak apa. Because it was our assumption. Okay. So dia dapat jawapan yang lain So sebenarnya soalan ni, oh tak apalah, saya tak payah cerita lah yang ni. Nanti korang confused. Okay, so next one. Two identical boxes, each of mass 30 kilogram are connected, what time is it? Are connected by a cord all over a smooth pulley. Okay, tell me, what does it mean when you have a smooth pulley, everyone?
Tension same.
Tension must be the same. Okay, so tension must be the same. So if I have tension over here, then it would be equal to the tension over here. So I have a question here. Doktor, maksud jalan kira still betul kan? Cuma assumption free body diagram tu je yang salah. Ya, betul. Your free body diagram is still correct walaupun assumption salah. Betul. And most of the time soalan macam tu yang ada kaitan dengan cari acceleration, dia tak include friction dalam free body diagram. Dia cakap smooth incline. So that your answer is not going to be affected by friction. So betul, free body diagram tetap betul walaupun jawapan A negatif. Betul. Okay? So don't worry about that. Asalkan jalan kira betul. Okay. Okay, so one of the boxes is on a horizontal table, this guy. And the other on an inclined surface of 30 degrees. If the coefficient of friction on both surfaces is 0.2, coefficient of friction is mu. Calculate the acceleration of the box and the tension of the cord. So ada dua benda kena cari, A and T. Okay, so now what is going to be our assumption for the motion? Which way? Yang nampak logik. Semua orang dah takut nak jawab dah. Ke bawah. Okay. So we are going with A going downwards. So if my A for mass 2 is going downwards, therefore this guy will have an A going to the right. They are connected. Kalau saya tarik seorang, lagi seorang pun tertarik juga. Okay, so I want my equation. Okay, let's assign this again. Kena buat laju-laju sebab kita nak masuk chapter 4. Kejap saya tengok ada banyak lagi tak. Okay lah, kita buat lagi satu and then saya, lepas daripada tu saya buat example laju-laju. So let me ask people yang saya belum panggil lagi. Okay, Najla tadi hutang saya. So Najla, can you please do free body diagram mass number 2? Najla ada tak?
Ada doktor, sorry tadi disconnect.
Okay, tak apa. Okay, and then Hasrin belum kan? Hasrin do mass 1 free body diagram. And then Rashida, condition and equation. Sebab kita nak laju sikit. And then Batrisha, condition and equation, sorry. Rashida is M2. And then, sorry, this is FX. And then Batrisha sama, M2, net in the FY. Okay, next is Khalida. Oh, banyak lagi nama, saya tak panggil lagi. Khalida, condition and equation mass number 1, net in the FX. And then Radin, condition and equation mass number 1, net in the FY. Okay, so let's give everyone 7 minutes, macam biasalah, 3:14. I want everyone to understand how to do the free body diagram, especially in linear motion. Please try it yourself. If your name is not here, just try it yourself. Make sure you understand what is happening. Okay. Ada soalan boleh tanya. Okay, how is everyone doing? Ni 2 minit. So your web assign for chapter 3, you lambat lagi. Saya buat 1 week after your penilaian 1. So you have 7 days after your exam. So don't worry about that. Kita akan habiskan hari ni. Apa tadi saya cakap? Lupa dah. I have a chat here. Doctor, is it possible to have 2 different friction for each box? Yes, sometimes we have different surfaces, so that is possible. But in this case, kita punya coefficient of friction sama. Coefficient of friction kita sama, tapi R kita untuk setiap ni lain kan? So friction diikut yang tu lah, diikut reaction force kita apa. So the factors that affect friction is the mu, is the permukaan, and also the reaction force. So yes, it can be different. Okay, so it's time. Najla, are you ready?
Yes.
Okay. So let's.
R ke atas upward.
Kita M2 kan? Okay, R dekat atas tu macam ni ke?
Tak. So nak cakap 90 degrees.
90 degrees with?
Kotak tu, M2.
Okay, so with the surface lah. Okay, so R 90 degrees to the surface. Okay.
Lepas tu bawah dia mg cos 30. Bukan. Yes.
mg cosine 30.
Lepas tu yang kanan dia tu mg. Opposite dengan tension tu mg sin 30.
Okay. Ada lagi tak kita tertinggal?
Friction.
Okay, friction
dekat T.
Dekat T. Okay, so Najla set friction sama arah dengan T. Kita tengok. Okay, anything else?
Tak ada.
Okay, thank you. Saya suka cara Najla describe, dia cakap mg cosine theta and then to the right mg and then to opposite to the tension is mg sin theta. So that was very descriptive. So bagus cara describe macam tu, lengkap. Okay, sekejap saya tulis elok sikit. 30 degrees. RT friction tertinggal. Friction. Okay, so next is Hasrin. Hasrin buat macam mana?
Ya. Mula-mula R ke atas.
R ke atas.
Lepas tu ke bawah mg. Ke belakang, ke kiri friction.
Ke kiri is friction.
Lepas tu dah.
Okay, dah. Okay. So thank you Hasrin. So free body diagram dah siap. Rashida, what is the condition and equation for M2 fx?
Net fx M2 equal to MA.
Equals to MA. Is it a positive A or a negative A?
Positive.
Positive. Positive ke kanan ke kiri?
Ke kanan.
Okay, so this is your positive A. Alright. So next, what is your equation?
Mg sin 30 and minus F minus T.
Okay, thank you. Good. Rashida dah Batrisha.
Net Fy M2 equal to 0.
To 0.
The equation R minus mg cosine 30.
Okay, good. Khalida?
Fx equal to MA.
Okay, Fx equals to MA. Okay.
Equal to T tolak F.
To T tolak F. Okay, Khalida, saya nak tanya kenapa awak pilih T sebagai positif?
sebab dia gerak ke kanan.
Okay, so dia gerak ke kanan. So acceleration awak ke kanan juga ke? Okay, so awak cakap A adalah positif. Therefore apa-apa yang ke kanan adalah positif kan? Okay. Thank you Khalida. Dah lengkap ke ni?
Dah.
Okay. Lengkap tak? Saya dengar macam ada orang nak jawab lagi. Okay, tak ada dah. So Khalida cakap lengkap. Radin.
Net Fy equals to 0.
Okay.
Which is equal to R minus mg.
Okay. Thank you. Kejap anak saya panggil. Yes. What is it, friend?
Come to my home. Come to mommy's home. Follow.
Nah.
Di follow.
Okay, good. I think everyone is getting it. So that's really good. Okay, so sekarang kita cuba solve lah. Kita cuba solve. So we want to solve for A and also for T. What should I do here? Any ideas? So we can solve for R from here, right? So R is going to be mg cosine 30. So this is specifically for mass 1. Mass 1 is mana? Oh, identical boxes of mass 30 kg. So sama je lah. Tak ada mass 1, mass 2 pun sebenarnya. Mass dia sama. So M is just M. There's no M1 and M2. The masses are equal. Kan? Okay, betul. So this would be 30, 9.81 and cosine 30, which will give us R as 30 times 9.81 times cosine 30. Okay, so this will be 254.87. So we know our R now. What next? Kita selalu kaitkan R dengan apa?
F.
Dengan F kan? Okay, so F is, kejap. Yusuf, turn down the volume. Turn down the volume. Okay, F is equals to mu R. So we have the mu 0.2. So this is specifically R1, R untuk mass 1. Kita tak tahu R untuk sini apa. So this is going to be mass 2. Ini mass 2, mass 1. This is mass 2. To this. Terbalik. Thank you. Okay. Yang ni adalah R1 and then kita solve for R2 over here, which is terbalik lagi. Sorry. This is R2 and this is R1. So R1 is from here, we have 0 equals to R minus mg. So R1 is basically mg lah, senang. So this is going to be 30 times 9.81 and R1 is 30 times 9.81. 294.3. Okay, so now from here, F1 is 0.2294.3. So that is times 0.2. So kita dapat friction. So kita tengok friction dia sama ke lain? Tadi ada kawan kita tanya, can friction be different? Kejap. No. Okay. So this is friction number 1 and then our friction 2. Let me write it here. Nak squeeze juga kat sini. So 254.87 times 0.2. Oh my god, bisingnya. Sekejap 50.974 ataupun 50.97 Newton. So the friction is different. Okay, come. Oops, sorry. Okay, sorry for that. Ada gangguan. So we have our friction force for mass number 2 and friction force for mass number 1. What next? What can we do? What can we do here? Kita nak cari tension and acceleration. So what? Apa kita boleh buat? Can we equate the two tensions together? Will that work? Boleh tak? Kita try Kita try. Okay, so we can try for that. Kita try to equate everything to become tension macam tadi juga. Okay, so T will become, the tension is equal, there's no T1, T2, it's just T. T will become, I bring this over here, MA bawa ke sini. So mg sin 30 minus F2. F2 is 50.97. And then this guy over here minus MA. Okay, so this is my first tension equation. Banyak betul bising hari ni. Okay, lepas tu this one, saya nak equate to T juga. So this is T equals to, I bring friction over here. So MA plus friction number 1, 58.86. So now I equate these two guys together. Okay, T and T sebab dia sama. Cuba tempat. Okay. So we write it here. MA is 30. A tak tahu. 58.86. Can someone calculate what is mg sin 30 minus 50.97? Tak belah sikit. So it's mg. M is 30 times 9.81 times sin 30 minus 50.97. So I get 96. Tolong double check kadang-kadang saya salah kira. 0.18 minus 30A. Okay, so now I have this equation. The only unknown I have is A. So now I can try to solve it. I have 60A. So 96.18 minus 58.86. So I get 37.32. Ada salah ke? Tak ada. Okay. Divided by 60. So my acceleration is positive, which means that our assumption is correct this time. Let me use a different color sebab tak nampak dah. So it's positive 0.62 ataupun 622 if you want to be more accurate. This is the answer. So our assumption is correct because we got a positive sign. We got a positive acceleration. So tak habis cerita lagi, kita dah tahu acceleration, kita nak kena solve for T. So acceleration for the mass 2 is the same as the acceleration for mass 1 because they are connected by a string. So kalau saya tarik satu box, the other box pun tertarik dengan acceleration yang sama. So I'm only solving for one acceleration. Sama juga dengan tension because it is smooth. I'm only going to solve for one tension. There's only a single tension lah punya value kat sini. Okay, so kita pilih yang paling senang. Mana yang paling senang untuk solve? Yang ni lah kot. So T equals to MA plus 58.86. So tension is equal to 30. A kita dah tahu kat sini 0.622. And tertambah yang ni 58.86. Okay, so that is our answer. Plus dengan 58.86. So tension is 77.52. Okay, so it's quite lengthy, but yang paling penting is here. If you get this part wrong, then everything else is wrong. Tak berbaloi pun buat equation panjang-panjang, equate this, equate that. Tapi kalau free body diagram salah, our condition salah, then everything else doesn't matter anymore sebab memang salah. Okay, so make sure this equation over here betul This is why I emphasize on the condition, emphasize on making sure you understand how to draw the free body diagram. Okay, so hopefully that helps. Okay, next this one, tak payahlah, yang ni sama je lebih kurang. Okay, kat sini soalan untuk web assign tapi yang ni tak assign tu korang. That's macam pantun pula. Okay, so the system shown below are in equilibrium. So A equals to 0. If the spring scales, so I have a question, kejap Doktor, why jawapan dalam buku is 77.46? Oh, ada jawapan kejap. Jawapan saya 77.52. Lebih kurang lah tu. Okay je tu. Maybe I have a slightly different decimal places. Kadang-kadang buku tak ikut 2 decimal places juga kadang-kadang. But dalam exam, please use 2 decimal places. So, Aida tanya kenapa jawapan dalam buku 46 bukan 52. Lebih kurang. Okay je. Okay, as long as jalan kira semua betul. Okay, going back to this guy. So the system shown below are in equilibrium. A equals to 0. Condition kita. If the spring scales are calibrated in newtons, what do they read? So kita ada spring This is penimbang yang spring tu. Macam ni. Ni dia tarik. Cakap Dia spring yang boleh timbang. Dia spring yang boleh timbang berat. Apa benda yang macam tu yang kita pakai? Entahlah, tak ada kot. Oh, bawang kat pasar pakai macam tu kot. Yang tergantung tu. Tapi tak tahu, tak sure Malaysia pakai ke tak. Okay, so kalau pergi pasar kan, apa dia? Ada Okay, sorry lah, saya tak selalu pergi pasar. So ada bawang dalam ni, dia gantung pakai spring. So dia dapat tahu apa weight bawang tu. Buruknya, okay. Bawang lah kita measure bawang. So but this guy, dia tulis kotak je lah. Nak senang hidup kan. Okay, so it's measuring the weight. So apa yang kita measure sebenarnya kat sini is we are measuring tension. So remember I told you, saya tak cerita lagi. So when we have a spring system yang measure weight, dia sebenarnya measure tension sebab dia connected to a string. It's connected to a string. So a force yang acting on the weight scale is tension sahaja. Apa force yang acting on this guy? It's only tension. Adalah mg, tapi mg tu dia tak measure lah. So kita nak measure tension. So this guy has mg ke bawah and then this t over here. And then this guy has mg and this guy is tension. So apa point kita nak buat benda ni? Saya nak tunjuk free body diagram je. And then for this guy, it is measuring tension from over here. This is a smooth pulley. So kita ada mg and we have tension over here too. Macam tu, okay. Then this one sama juga, dia measure tension. This guy has the same tension, R, mg. And then we are going to assume it's trying to slide down here because kita punya komponen mg ke sini. Mg cosine theta, and then this is mg sine theta. What else? We should have a friction, or if we are assuming it's frictionless, then there's no friction. Boleh juga. Soalan dia tak spesifik. So here mg, kat sini adalah, sorry, dia cakap pulleys and incline are frictionless, so we don't have to care about friction. So mg is tension over here. This is mg. And then tension over here. So what is this guy measuring? It's measuring, so this guy is T, this is T. Okay, and it is measuring this capital T. So this capital T, this capital T pula. This T is not equal to this T and this T. So I would say this is T1 and this, if this is T2, this is also T2. So dia tak sama So T1 is equal to 2T2. Macam tu. So this is the free body diagram. Okay, ingat tak kita buat traffic light hari tu? Traffic light pun ada. Dia macam ni kot, silap saya. Gambar macam mana? Dia macam ni, dia macam tu. This is the same case. If you guys still remember. So there is a traffic light. This is connected by a string. So I said this is mg and t. But what about the system over here? Orang ni pun dia nak free body diagram juga. So it is T1, T2, T3. This is T3. Macam tu. Okay, so we don't know what it is sebab dia tak bagi kita values ataupun condition ke apa ke. So this is the free body diagram. You have to know how to draw the free body diagram. Okay, so again, this guy is measuring tension. I want to draw the free body diagram for the objects and want to know if the tension tu sama ke dengan yang ni. So kat sini dia tulis M, yang ni pun M, maksudnya dia ada mass yang sama. So kalau mass dia sama, tension dia sama, tension sama, tension sama, tension sama. A equals to 0, so net in the Fx is equal to 0, net in the Fy is also equal to 0. This is also M, Mg, tension, tension. Tension, Mg, tension, Mg, M sama, so tension sama. And then this is going to be T2 lah, sebab dia kena sama dengan atas ni. Atas ni tak sama dengan T2 kat bawah ni, so dia T1 sahaja. Okay. Ini biasa je lah, tension connected to a string, Mg, R, friction tak ada sebab frictionless. Okay, so saya go over je untuk pendedahan free body diagram untuk spring system. And then this one, I don't think we have to do it sebab kita dah buat example yang sama. So I think we are done with chapter 3. Okay. See. Ada soalan tak pasal chapter 3? So let's finish the next 20 minutes for chapter 4 and then kita cuba habis early sikit lah. Sebab semua orang mesti dah tak larat. Sama pula dia save. Tak apa, kita berehat dulu sambil dia save ni. Sama betul, dia memang nak kasi korang rehat ni. What is going on? Aduh. Ni dah kenapa? Okay, kalau tengok kat sini kan, yang ni soalan web assign ada dalam korang punya assignment. Dia cakap frictionless pulley. So tension akan sama. And then lies on a smooth incline. So there's no friction. So that is the keyword that you need to be aware of lah. Frictionless incline, there's no friction. Weh, lama gila. Sekejap. Dah kenapa entah. Okay, save. Okay dah. Okay, now I'm going to share chapter 4. Mana chapter 4? Desktop. Right. This is weird. Sekejap. Doktor, kalau soalan subjektif, nanti last kali kita akan dapat acceleration dia negatif, maksudnya kita kena betulkan balik equation and also free diagram kan? Tak. You don't have to change anything, just leave it as it is and just give a remark macam the assumption for acceleration is in the opposite direction of the actual acceleration, macam tu lah. Just tell me that you understand what it means to have a negative acceleration. It just means that your assumption is in the opposite direction. Tak payah tukar apa-apa. Bagi je jawapan macam tu. Okay, sebab jawapan tu betul. Assumption je yang salah. So assumption kita tak penalize and in physics kita banyak sangat assumption sebenarnya. Because we are just approximating things. Okay, kejap saya cari mana entah. Doctor, my question is out of physics topic, but when will we go to campus? Okay, so saya ada forward kat korang PDF document tu. Dia cakap kat korang, dia cakap dalam dokumen tu, you guys will be coming back to campus secara berperingkat 15 Oktober. But kita tunggu arahan UPM apa, sebab yang tu KPT kan. Event ultimately kita kena follow UPM punya decision. Tunggu dulu tak tahu, saya pun tak tahu. Saya pun tak balik office lagi ni. And I hope we can go soon. So first time saya mengajar tak jumpa langsung student saya. So quite sad actually. Tapi tak apa, kita sama-sama tabah supaya semua orang selamat. Tak nak siapa-siapa terkesan dengan COVID. So semua orang kena berkorban lah. And make sure you guys are vaccinated. Oh, kalau tak silap saya, semua orang kena fully vaccinated baru boleh balik campus. Tak silap saya. So if you have not gotten your appointment, please ask the help desk. Tanya help desk My Sejahtera Try to schedule an appointment soon. Okay. Kalau yang belum dapat dos lah. Kalau yang dah ada first dose, tunggu second dose, tunggu je lah. Okay. It will come in the system. Okay, so kita masuk chapter 4. Kita buat lead back je sebab tinggal berapa minit je pun. So chapter 4 is about work and energy. So work and energy ni ada kaitan dengan force. So sebenarnya chapter 3 pentinglah untuk kesinambungan chapter 4. So chapter 4 is about work and energy and it is related to force. So for this chapter, we are going to learn on work, energy and power, mechanical potential energy and also conservation of energy. So in Malay, I think it's called keabadian tenaga. So this is what it is. Okay, so work and energy. So after completing this chapter, this is our learning outcome. Define and calculate work by force. Like I told you before, it is related to force. And then relate between work, energy, and also power. So these are three things that are new in this chapter. State conservation of energy and solve related problems. There's another learning outcome that they always forget to put inside this slide, which is understanding the kinetic, the work energy theorem. Ini pun kena ingat, selalu keluar soalan macam ni, the work energy theorem. So, tak tahu kenapa diorang tak letak dalam learning outcome when they ask this in exam. So saya letakkan untuk korang. So understanding the work energy theorem, penting So nanti kita akan belajar. Alright, so what is work, energy and power? I don't know what the relation is to this picture. Hiasan tu. Okay, so work done by a force. So work done, the equation is actually, I'm going to introduce to you the work done. Work done is actually F dot delta X. Dot product, bukan multiplication, it's a dot product. So remember what I told you about dot product. Dot product means that when you expand it, it becomes F delta X cosine theta. Now, why is it a cosine theta? Because we want to know what is the force that is parallel to the displacement ataupun what is the force that is acting in the direction of displacement. So if you guys look at this one, you have this force, which is a pulling force, F pull, by this lady over here, and the box goes to the right. So this is the displacement of the box. Now it's asking what is the force acting in the direction of displacement. Force acting in the same direction as displacement ataupun parallel to displacement. Or parallel to displacement, to delta X lah. Force acting in the same direction or parallel to X. Now we have this force vector. Remember, we can resolve our force. So when we resolve it, it becomes F sine theta, and this becomes F cosine theta. So the only component of force that is acting in the same direction or parallel to displacement is only F cosine theta. So your equation becomes W ataupun work done equals to F cosine theta darab dengan delta X. So this is the equation for work done. Work done is a scalar quantity. It's not a vector. Okay, so it only cares about the parallel component yang dalam sama direction dengan displacement. Kena sama ataupun parallel. Okay, so let's look at this guy pushing this piano. Okay, so dia, kalau kita lukis free body diagram dia, let's draw it. Free body diagram, MG. Korang ingat korang dah terlepas free body diagram kan? Ada lagi, chapter 4 ada lagi. So this is R. Okay, so you have your force this way. So like I said to you before, yang paling accurate untuk lukis free body diagram adalah daripada center kan. So walaupun F kita macam ni, kita sambungkan kepada center dia. Macam ni. So it will become, this is the way. So R, F, MG. So anggap ni ada angle, some angle. We don't know what the angle is. So we resolve this guy to be mg sine theta. Cosine. Cosine theta. And this over here will become mg sine theta. Okay, so my question is, which force is acting in the same direction as displacement? Ataupun which force is acting parallel to displacement in this case? Which force? Ada nak jawab tak?
F.
F. Okay, ada lagi tak selain F?
mg sin theta.
mg sin theta. So ada dua kat sini. In this axis that is parallel to our displacement. Or displacement is going that way, right? The incline kan? So the forces acting in this direction is F and also mg sin theta. So dua-dua ni ada effect dekat work done. So kita boleh cakap work done ataupun work done on this piano, okay, in the same direction as this displacement, kita akan cakap F net. F net and dot product dengan displacement. And then daripada F net ni, saya nak tahu apa yang parallel sahaja dengan displacement. So F net ni kita akan ada Fx, kita akan ada Fy, betul tak? But I only want to know what is acting in the X direction. So this guy becomes F net ataupun kita buat yang kita faham lah kan. So I would say this is net Fx. Sebab net Fx je yang sama direction dengan displacement, betul tak? So takkan saya nak letak net Fy delta X pula kan, dia tak parallel. So kita nak parallel forces sahaja. So it becomes net Fx times displacement. So what is the net in the X direction? I have pushing force minus mg sin theta darab dengan displacement. So this is my work done. Okay, so dalam piano ni punya free body diagram bagi tahu kita we have a pushing force and we have mg sin theta. So work done on the piano is the net force darab dengan the displacement. So the net force kat sini ialah F push minus mg sin theta, and then we know that whatever that value is, F minus mg sin theta, multiply with the displacement, then you get the work done on the piano. Okay. So that is a lengthy introduction. Nanti kita go over lagi benda-benda macam ni. If you guys don't really get it now, tak apa, sabar dulu kan, bear with me. Okay, so work done by a force. Work is the quantity that relates force on the object. So we have a force acting on the object. Kalau force ni dekat sini, dia tak sentuh object, that is not related to the work done on the object. Kita nak force yang acting on the object sahaja. Jangan ambil kira benda lain. Sama macam free body diagram lah. Okay, so force on the object and the displacement of the object. So this object is moving by delta x. So there's two quantities that will tell us the work done, which is F, the component of F that is parallel to displacement. The component of F that is parallel to displacement. In this case is F cosine theta. So work done is F cosine theta darab dengan delta x. Mana pergi dot product? Dot product tu saya dah expand lah jadi cosine theta. So kalau saya nak tulis macam ni, I want to write it like this, F dot delta x. When I expand it, it becomes F cosine theta delta x. It's the same thing. Okay, so it is a scalar quantity. Okay, next. Definition of work done by the force on the object. So it's the same parallel component of the force in the same direction ataupun parallel to the displacement. Parallel maksudnya dia boleh ke kanan, boleh ke kiri walaupun displacement ke kanan. So my force, saya boleh cakap saya nak tolak macam ni. Boleh. Tapi force komponen yang parallel kepada delta X ni adalah ke kiri lah. Nanti kita akan tengok example macam ni. So it means that work done ni is the force that is parallel to the displacement. It's not necessarily in the same direction, but it is parallel. Boleh jadi same direction ataupun boleh jadi opposite direction asalkan in the same axis. Axis yang sama dengan motion ataupun displacement. Okay, so the unit. So kita tahu the equation is work done equals to F delta X. F is Newton, delta X is meter. So work done is Newton meter or joules because it is energy. Work done is in energy. This is it. Newton meter or joules. Sama macam kita tahu Newton is in Newton. Force is in Newton. But we can also say that it is kilogram meter per second squared or Newton. So it is a derived quantity, but this is the SI unit. This is a derived quantity, but this is the SI unit. Okay, so both are correct. Okay, so there is no work done if force that is parallel to the displacement is equal to 0. And there is no work done if delta X is equal to 0. What does it mean when delta X is equal to 0? It's not moving. The object is static. Tak boleh tulis pula. Static, it's not moving anywhere. Therefore, our displacement is equal to 0. And then it is also equal to 0 when your angle theta is equal to 90, which means that you will get a cosine of 0. Okay, so there are three factors that makes work done equal to 0. The first one, force. But force kat sini kalau kosong, kosong lah. And then if delta X is 0, then this would also be 0. Cosine theta becomes 0 if it is 90 degrees ataupun it is the F sine component. It is perpendicular lah to displacement. Macam ni Kalau displacement ke sini, awak kasih saya force macam ni, then it is going to be 0. Sebab cosine of 90 is 0. So tak boleh. Perpendicular forces will not give us work done. Okay. So these are the three things that can make work done equal to 0. Okay, next. From this equation, we know that work is positive if the theta is from 0 to 90 degrees. Or I would say that it is in the same quarter as displacement. Okay, displacement kita ke kanan kan? Kita cakap ni first quarter lah. First quarter of our axis. Okay, so both of them are in the first quarter. So if I resolve my F, it will become Fx and it would become, let's use a different color lah. It would become bad color. Yeah, let's use green. Bagi nampak sikit. So, nampak tak? Boleh lah. So that is Fx. Okay, so if I resolve my F, I get the Fx over there. And Fy, which I don't care because this is work done. So Fx is in the same quarter as displacement. Therefore, it is a positive work done. But if my force is not in the same quarter as my displacement is in the first quarter, this guy is in the second quarter. So kalau saya resolve, pakai orange lagi. Kalau saya resolve, the Fx is the opposite direction. So this will give me a negative work done. So how does this relate to this statement? So work is positive if theta is 0 to 90. 0 to 90 is over here, first quarter. Okay, first quarter with respect to the displacement. And then work is negative if it is 90 to 180. Daripada sini ke sini. with respect to the displacement. Sekarang ni kita anggap displacement kita ke kanan kan. So this is with respect to displacement. What if your displacement is to the left? Okay, what if your displacement is to the left? And my force is like this, F1. And I have another force this way, F2. Which will give me positive work and which will give me negative work? Anyone?
F1 positive.
F1 will give us positive work and F2 will give us negative work. Let's try to resolve it. If I resolve F1, I will have an Fx in the same direction as X. So positive lah. So if I resolve F2, it will be Fx over here. And this is opposite direction to my displacement. So I get a negative work done. Okay, so ni ada contoh-contoh sikit. Work can be positive or negative. I told you just now, work is a scalar quantity. So how does it have a positive or a negative value? So a positive value simply means that the F and displacement are in the same direction. Itu sahaja. Itu sahaja. It's not a vector. It's just telling us, oh, the force and the displacement are in the same direction. It's an indicator lah, indicator. And if it's a negative work done, we know that force is not in the same direction as displacement. So it serves as an indicator for us. Okay. So this is more examples. This is F. Displacement is like this. This is displacement. If I apply F like this, Fx is in the same direction as delta x, positive, work done. F is in the same direction as delta x, positive, work done. Fx is in the same direction as delta x, positive, work done. This guy, if I resolve it, it's this way and this way. Tapi kat sini dia tetap macam ni, sama juga. So it's to the right. So it's in the same direction as delta x. Okay, so this is examples for work done that is negative. So if I resolve my force here, it's to the left, displacement is to the right, negative, work done. This one, opposite, negative, work done. Opposite with force and displacement, negative, work done. This one, resolve it, negative, work done. So semua kat sini negative work done lah. Okay, so these are different instances where you would have a work done that is positive, negative. Okay, angle dia adalah from 90 to 180 with respect to the displacement. Kat sini lah. Apa-apa yang dekat sini akan jadi negatif. Okay, 90 to 180 degrees. Okay. Okay, so saya akan cerita pasal this concept in next class. Kat sini dia cerita pasal work done by force of gravity dengan pushing force. Ada seorang jadi negatif, seorang jadi positif. So this is quite confusing. So I want to dedicate some time on this one. So let's continue in next class. Does anyone have any questions so far? Is everyone okay? Just tired? Okay, let's just end class. Okay, bye guys. Have a great rest of the day. All the best for your exam. I'm rooting for you and I still owe you Web Design Chapter 2 nanti saya bagi. Okay, bye-bye guys.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Terima kasih,
Thank you, Doctor.
Doctor.
Thank you, Doctor.
Doctor.
Bye.